Thank you very much, General Swan. Good morning. We're here this morning for the panel on mission capacity and readiness for the future force. It's my pleasure to introduce our sponsor, the Acting Deputy Assistant Secretary of the Army for Energy and Sustainability, Mr. Jack Surash. He'll be our opening speaker. I'd also like to introduce the other panel members. On my right is Dr. Norma Jean Mattei, the President of the American Society of Civil Engineers. On her right, Ms. Pamela Maines, the Executive Director for Federal DE Sales at Constellation. And then Brigadier General Michael Stone, the Assistant Adjutant General for Installations from the Michigan Army National Guard. So we'll open with statements from each of our panel members here at the table, and then we'll work through the questions that we get from the audience. Mr. Surash, over to you.
Thank you. Boy, really happy to be here. If I can get my first slide, please. Great. Thank you. So I've been on the Army staff about 6 months now, so I think I know my way around fairly well. In fact, I had a great general officer meeting yesterday, and when I first arrived, I was fairly scripted, but yesterday I had absolutely no script, and General Harrison and General Royalty and myself had a lot of fun. So I'm going to talk about three things today, just to give you a quick preview. I'm going to talk about the Army's energy security and sustainability strategy. I have one copy here. This is a document. Anybody that is interested in what we're doing, and especially for any of the companies that want to do business with respect to energy and sustainability, if you've come to visit me, I've given you your own personal copy, but it's on the web. Please get it and get your head around it, and please help us. We'd really appreciate that. Next slide, please. So I'm just going to use this as a background. Those of you that are in the Army or have been with the Army know far more, about the Army installation business than I do. So, it's huge. Army installations is a huge business, over 150 installations around the world. And of course, and by the way, I'm going to talk about the energy security and sustainability strategy. I'm going to talk a little bit about a net zero program the Army has, and I'm going to show you some pictures of some really neat projects in the energy world that we've got going on. So obviously, energy security and sustainability are critical Army priorities. From my view, energy is key to everything the Army does. And obviously, I believe the Army requires a reliable energy supply in order to conduct its mission, especially these days with it seems like the ever-increasing use of things that require energy and for the most part, electricity. But when you look out there, there have been energy supply issues, there have been shortfalls, there have been increasing power distribution failures. I'm personally happy, but yet surprised that there haven't been more severe disruptions, caused by bad actors, serious weather events, things like that. But obviously, that's a vulnerability to the Army. So in the center of the slide here, I've listed an Army directive, and this directive was signed exactly a month ago by our Acting Secretary of the Army, Spear. And this is a really big deal, for energy and sustainability. So I'm going to give you a little bit of background on what this directive is about. And for those of you that have served in the Army or in the Pentagon, whether AUSA or the Secretariat, you can imagine getting the Secretary of the Army to sign a directive is no easy task. So I was really delighted that we got this across the line about a month ago. So the purpose of this directive is to establish a requirement for the Army's energy and water security, so we can enhance the resilience of Army installation. So there's some really big things in this directive. So it establishes an overarching Army energy and water security policy to sustain critical mission capabilities and to mitigate risks posed by energy and water disruptions that are affecting our installations. The policy states that the Army will prioritize energy and water security requirements to ensure available, reliable, and quality power and water to continuously sustain critical missions. And a real specific point that this directive is requiring that installations be capable of providing power and water for a minimum of 14 days in support of critical missions. So I think this has been something that's been missing. I think there's been great interest in doing this across the Army, without a doubt. But what was the requirement? Was it 1 day? Was it 3 days? Was it 5? Was it 30? So as a starting point, this may not be perfect, but we arrived at a 14-day requirement, and that was arrived at by looking at outages and mission requirements and things like that. This applies to the entire United States Army, all installations, the 4 landholding commands. It does not apply to two specific sectors of the Army. It does not apply to Army contingency bases, and it does not apply to the Corps of Engineers Civil Works facilities. So a big deal, and those of you that are, have greater interest in this, and those of you that want to do business with the Army to try to help us with this, please just go to our website and you can take a look at that directive. So obviously energy security and resiliency, you've heard, I think most of the speakers talk about this, is really critical, for the Army. In FY16, the Army spent on the order of $1.2 billion on energy at its installations. I believe the Army's budget in FY16 was about $148 billion, plus or minus, so this is a sizable amount of money. Okay, I'm going to talk a little bit now about the energy security and sustainability strategy. If I can have the next slide, please. I'm just going to quickly walk you through this. So this is the Army's roadmap to a more adaptable and resilient force. And there's an awful lot of uncertainty and changes today, and going forward. So it focuses on 5 things, and I've listed them here. And so, with respect to the first one, the ES2 strategy will inform decisions by ensuring the Army planning and decision-making processes fully consider current and long-term implications of our resources. And for these 5 different goals, we have typically 2 or 3 sub-goals under them. And this goal applies to, to everybody in the Army, certainly the installations and all the operational energy, sorts of considerations. The second goal is about optimizing use. So obviously there we want to minimize demand, we want to increase efficiency, and things like that. Third is about assuring access, and we want to maintain reliable access to energy, to water, and also land, quite frankly, at our installations. The fourth is about building resiliency, again, at our installations. And finally, innovation. We've got to really advance things, test, field new processes and things like that. So this is a major effort. This strategy is a little bit less than 2 years old. It was released in May of 2015 by the then Vice Chief of Staff for the Army and the then Under Secretary of the Army. So again, another big deal. Obviously a lot of work went into this, and there's a lot of work going on to to implement this across the Army. In fact, a couple weeks ago I went to Fort Bragg, and I was really delighted because Fort Bragg DPW did not put together a special briefing for me. They basically used their quarterly ES2 briefing to tell me the energy and sustainability sorts of things they wanted to go over with me. So that was just great. All right, the second item is net zero. Some of you may have heard about this. Some of you may have not. It's a really neat program, and essentially what we're trying to do there is bring overall consumption of resources on installations down to an effective rate of 0. So we're trying to look at this at an installation level. In some cases, it's at a building level. So essentially, what we're looking to do here is a net zero energy installation produces as much energy on site as it uses over the course of a year, okay? With respect to water, a net zero water installation limits the consumption of fresh water resources and returns water to the same watershed, obviously in order to maintain the quantity and quality of the region's groundwater and surface resources. And finally, a net zero waste installation reduces, reuses, recovers, waste streams and converts them into resources in an attempt to zero out, use of landfills. So this program began with a pilot, I think about 7-8 years ago, but it's now been expanded across all installations in the Army, and we're seeing some really good results from that. So lots of really neat things going on. So the third part now, if I can go to the next slide, please. And I know you can't see that most likely, but I just want to. I'm trying to just depict that we've got a lot of energy projects going on, and with respect to renewable energy, the Army now sits at about 320 megawatts of energy capacity. Most of these are located on Army installations or very near them. And we have a central office. It's the Army Office of Energy Initiatives that is undertaking this program. And this is really an energy security play. An energy security and sustainability play is what I would suggest. So I'm going to quickly walk you through 3 projects. I've got a picture of each. And what all these projects are about is we're attempting to support energy and water security. Obviously, these projects do a number of things. They create energy-related jobs. Think about it. They actually boost domestic energy production. That's called for in the President's and America Energy First plan. They help installations gain energy independence. Typically, they're very clean, so they're protecting our clean air and water and conserving our resources. So I'm going to talk real quick about Fort Gordon. A project down at Fort Gordon, a project out in Hawaii at Schofield Barracks, and an upcoming project at Los Alamitos. So next slide, please. So this is Fort Gordon down in Georgia. This is operational. So all 3 of these projects are, and maybe I need to come up with a more artful term, but this is other people's money. Okay, so. If anybody has a better idea on what I should call it, let me know, please. But essentially, the Army investment consists of a relatively small amount of money for planning, National Environmental Policy Act, and real estate coordination and things like that. In this case, it was Georgia Southern that did this project. So the Army spent a little bit of money for planning. We are letting them, we did an outgrant for about 270 acres of land on that installation. And what Georgia Southern, this is probably a $60-70 million investment by them. So they put in a whole bunch of solar panels. It's like on the order of almost 140,000 solar panels across about 230 acres. So it's a monster solar farm. It's 30 megawatts. So what 30 megawatts, that would fully power about 4,300 homes 24/7 all year. This is a 35-year deal. But now, to be clear, this has some energy security attributes. This is a distributed generation source. So in the utility industry these days, this is typically what utilities are trying to do. They're trying to build generation sources, multiple generation sources instead of central large ones. Now this is not connected straight to Fort Gordon. We've got some more work to do here. We in the future we'd like to get some storage assets and maybe a microgrid in place so that Fort Gordon would be able to use fully utilize the capabilities of this solar farm. But it doesn't change our electric bill, so pretty neat investment. Next, please. This is probably the premier example of what we're trying to do. So this is on the island of Oahu. By the way, in a previous life in the Navy, this was one of my many difficult assignments I had. My first assignment in the Navy was as an activity civil engineer at what was then called the Public Works Center in Pearl Harbor, Hawaii. And after that, it just kept getting harder. My second assignment was on the island of Kauai, and I'll stop there and not mention San Diego, Madrid, Spain. I did 10 years in Washington, D.C., so that was a little bit of payback maybe. Okay, so here's the deal out in Hawaii. So again, the Army paid a little bit for planning and things like that. In this case, we provided Hawaiian Electric Company 10 acres of land. So now what is the Army going to get? And what's Hawaiian Electric going to get? This project is under construction. It will be completed next spring, and it's going to be a 50 megawatt plant. What the Army will get out of it is if there is a problem with the grid or a contingency of any sort, essentially, this is a black start capable diesel fueled plant. So at the press of a button, this plant goes on. It will actually take a couple hours for us to coordinate all the switching. There is a microgrid installed, et cetera. But this will provide not just the critical power. This will provide 100% of the power needed by the Army for Schofield, the Wheeler Airfield, the Kania site, and it has enough electricity to power at least a community hospital on the outside. So that's a pretty neat deal for the Army, and we're not paying a cent more for electricity. They can provide this to us for up to 30 days, and our bill would not change, one bit. Now, what does Hawaiian Electric get out of it? Well, it's probably not the easiest thing to find 10 or 11 acres of land on that island that you can build a small power plant on. So that's one thing they got, from the Army. But what they're going to use this for is when their grid, when they need more electricity supplied to their grid, they'll obviously turn this on and they'll use it to generate electricity during those times. And the other thing I'd point out is this is, of all their generation assets on that island, this is the only generation asset that Hawaiian Electric has that is above the tsunami strike zone. All their other assets are right down near the water. So a neat project. This is under construction, will be completed in about 1 year. And lastly, an upcoming project out at Los Alamitos. This is a more complex project. So what we're, but it's a similar thing. It's other people's money. So this is about 115 acres, possibly at play. Proposals are not yet even in on this. But we're looking at a combination of natural gas generation, some solar, microgrid, battery storage, and what the Army will get, again, is if there is a contingency or an issue that, this will feed Los Alamitos, 100% of its energy requirements. Proposals will probably be in within 6 months or so, and hopefully in 18 months or so, this will be in construction. So I just want to wrap it up. So some really neat things going on with respect. I think we've got a good strategy in place with respect to energy and water security. Good things happening with the net zero program, and some good things going on with respect to renewable and alternative energy sources. In an attempt to help with resiliency and energy security situations at Army installations. And I can talk a whole lot more, as you can tell on this. This is a really exciting thing for me to talk about, but I need to stop because we've got some real experts on this panel that we need to hear from. But I appreciate AUSA, having this get together today. As others have said, it's great for us to be able to tell you what's going on, but it's even more important to hear from outside experts on your views as the Army moves forward. So I will stop there. Thank you.
Okay, thank you, Mr. Surash. Dr. Mattei, could you talk to us a little bit about how the status and the future of the built infrastructure would complement these energy discussions we just had about how installations would support Army readiness in the future?
So, Craig, I'll be glad to. I think I am going to stand up, and I do have some slides, so sorry about that. So, first slide. Before I start about, because I'm going to kind of broaden what we're talking about, not about infrastructure on installation, but just infrastructure that we rely on, regardless of whether you work with military or happen to work at that. Before I do, I want to tell a tale because I just came back last night. I was with several of our younger members in New York City, and we talked about Sandy. And I mentioned that I was going to come here, and I was kind of wondering, and I was worried because of all the acronyms that are going to fly around, and I don't know all your acronyms, I know my acronyms. And I told them about energy and how y'all are going to have to, 14 days be able to run. So we had a previous panelist that mentioned that warned you that a disaster is going to happen. One of those disasters happen to a community where you have an installation that has the lights on. So there will be a beacon amongst the dark. You will be the have in the middle of the have-nots, and the have-nots are really hurting. And what drove that home to me is talking to these younger members that are all engineers working in big, tall buildings right next to Wall Street. So what happened in Sandy? The stock market knew that they had to run no matter what, and they were prepared. They ran. Nobody else was. So these young, I just looked at their faces and they weren't happy about that. So please think about how you will be good neighbors. Help them talk about standing up their emergency ops. I don't know. Just be good neighbors. So, or you're going to get a black eye. So now let's take a look at. We put out a report card on America's infrastructure, and we've been doing this since 1998. We don't talk about DoD installations or anything owned by DoD. We do talk about civil works, so that's clearly something that we do. So since 1998, we've been doing this every 4 years, and we use the format that you know and love as kids. A is good, F is bad. So what does A mean in infrastructure? Well, that infrastructure has, and this is just an average over 16 sectors and then an overall grade across the country. So it's not project driven. We get our data from government agencies at federal, state, local, and county level. So we don't bring this stuff up. So we're just getting data and using it in an aggregate form. So we've been doing this again as every 4 years. So our grade last time, 2013, overall was a D+. So let me talk before I go to the next slide. And A means that infrastructure still has that new infrastructure smell. It was designed and constructed using modern methods for the future capacity. Or it's been retrofitted. So that if it was my car and I drive a 2012 and I wax it, it goes to the mechanic, I make an appointment with the mechanic and everything, I make sure that my car is in tip-top condition. But when I have to back up, I have to turn around because my 2012 doesn't have a camera and it doesn't. So if you want an A, you would have to put all those bells and whistles on your infrastructure to get an A. So A is kind of, as a whole, we're not striving there. We're trying to strive for B. B's in really good working order, good condition. It is fit for use. It has sufficient capacity for now and for the future. C, it's all right. D, well, you deferred maintenance. Some of the parts, some of the pieces, they're at risk of failure. And F is, it's not fit for purpose anymore. So that's what those grades mean. Next slide. 2017, last week. It ain't good. So, overall grade, still a D+. It was a D+ in 2013. Some of the sectors, and I know that this might be hard for you to see in the back, so we look at aviation, bridges, dams, drinking water, energy, hazardous waste, inland waterways, levees, parks and recreation, ports, rail, roads, schools, solid waste transit, and wastewater. So a lot, but not all, of the critical infrastructure that we as Americans rely on for our quality of life. The green arrows mean that from 2013 to 2017 grades were better. The red arrows mean they were worse. So you see a lot of green arrows, you see some red arrows. That's why our overall grade of D+ didn't move. 2013, same overall grade. Before I move on to the next slide, I'll tell you what the best performer and the worst performer was. So these grades aren't, you see a lot of D's there. If my kids came home with a D, I'd say, give me the car keys, because they can do better. We can do better. So best performer was rail. So not passenger rail. Passenger rail is dragging the rest of the rail community down. Freight rail. Freight rail is primarily private and a lot of private investment. 2015, over $20 billion dumped into freight rail. They get a B. 4 years ago, they got a C+. They jumped over B- to a B because of private investment over that 4-year period. They also wisely used the Tiger grants to innovate. So they're innovating. So doing some good stuff. They're starting to look at their whole system, operating the system, double up, increase the capacity of trains without increasing the length of trains. Smart, right? So, rail, our star pupil. Transit, the poor performer. So a lot of you might have come here on the Metro. I Ubered because Sunday I came in, 2 weeks ago, Sunday, I had come in, I was tired, it was nighttime, and I loved it because I was right on the yellow line. Came into Reagan, I'm getting on, I love the Metro. But it's late and I'm tired. And my hotel was a half a block off of the yellow line. I'm thinking, I don't even have change. I was wrong. It was Sunday night, it deferred maintenance. So when they maintain, they gotta shut the sucker down. So I get off that one, they stop the train. Everybody off, go to the shuttle, take the shuttle, go back down, get back on the train. Deferred maintenance, that is the price we're paying for deferred maintenance. Transit, it's like that all over. So we've just not invested and we're having deferred maintenance issues. Trying to move people more efficiently, get them off the highways, they're not so good either, right? So transit does have a few bright spots. So we have some communities, Los Angeles, Phoenix, and Seattle, investing in transit. Or the grade would be worse than a D-. Okay, next slide. So what are our needs as a nation in those 16 categories over the next 10 years? So this is not just at the federal level. This is federal, this is state, this is county. A lot of infrastructure is owned by the county. This is city. This is some private investment. So if you tally all, these are the needs. If you look at the needs for the next 10 years, $4.6 trillion. We do spend money on infrastructure, and we are increasing the amount that we spend on infrastructure in all levels of government with private monies, about $2.5 trillion. So over the next 10 years, if we want to get to not an A, but a B, we need $2 trillion across all levels of government plus the private sector. It's a lot of money. But we're bearing the costs to our economy of not investing. So how do we close that gap? Next slide. Well, it's three-pronged. So we're going to need to invest. So we're going to need some leaders to stand up and invest. We're going to have to invest not only at the federal government level, but at the state, county, municipal levels, and with the use of private investment, if the infrastructure is private, or P3s, P4s, where the projects make sense. We need bold leadership, and we need to prepare not just for, and we heard this before this morning, not just for today, not just for tomorrow, but for the decades in the future. Next slide. So a little bit about investment. We currently spend about 2.5% of our GDP on infrastructure. That's about the same amount as Canada and most of Europe. China, 6 or 7. Some of the developing world, a good chunk, they've got small economies and great needs. So they're trying to put in, they're not putting in landlines, they're putting in cellular towers. So they're putting in the new stuff. We have to put the trust back in trust funds. So we have to use monies that are allocated to certain things on those things that they were meant to be allocated. We've got to fix the highway trust fund, and this is gonna be something that I know a lot of people don't like, but at the federal level, we really recommend that we increase the motor fuels tax. It hasn't been, at the federal level, increased since 1993. It has not been indexed to inflation. So just imagine operating your family on your 1993 budget today. You wouldn't be happy. You wouldn't be, if I did that, I wouldn't be able to afford to send my kids to the college he's going to right now. So we have to do something. We as Americans have got to just understand that we have to pay for the infrastructure that we rely on and that we enjoy, even though it's not, it's lost a long time ago, the new car smell. I mean, the new infrastructure smell. We have to authorize programs. We have to use what monies we have more wisely. So we have to manage risk. So figure out where our biggest risks are and put the monies where that buys down the most risk. It's the smart thing to do. We don't necessarily do that. And there's a difference between funding new and maintenance. So what we do, when we do fund infrastructure, we usually just talk about upfront costs, and that's not just at the federal level, at state, local. We really have to start thinking about where's the maintenance monies coming from. So next slide, leadership and planning. So we actually are recommending that any project over $5 million that receives federal funds must use life cycle assessment. So we realize that infrastructure usually has a very long life. Most of the cost over the lifetime of the infrastructure is in operations and maintenance. So we tend to put the cheapest thing in the ground, and then we spend a whole lot of money on operations and maintenance. So if we don't look at minimizing total life cycle costs, using innovation, building in resilience, then you're going to reduce the cost of that lifetime cost. But that might mean that you're spending more money up front for something that's going to overall, over the lifetime, cost less. Really, we must start streamlining the permit process. Maybe some parallel permitting assessments. That would shorten things up. And then develop a list. Kylie had mentioned the right projects. You know, we have investors that are eager. The federal government, the state government, city governments, they look at that as a pretty good risk. It's not risk free. But you know, I don't think we're going out of business. So, but where are the projects that make sense? Because not all projects doesn't. We have done the changes to the federal legislation and eliminated some of the barriers to using P3s for surface transportation. So you see the toll road, you see in water also, and schools. So there are public-private partnerships that are going on. You can go to the FHWA website and take a look. There's a bunch of good examples of public-private partnerships in that sector. But it took some changes in the regulations that enable TIFIA, helpful tool. But you have to know where those projects are. And a professional organization such as ASCE might be able to, through its membership, develop some type of a list, because we have 150,000 members, not all of them, but most of them U.S. And we're in all of that infrastructure that we just graded. So we might have a good idea of where those projects might be. Put everybody together. Next slide. So the third solution would be to prepare for the future. So when a piece of infrastructure gets hit by some kind of catastrophic event, be it a natural or a man-made disaster or a multi-hazard, you want that community to get back on its feet as quickly as possible. You want it to be resilient. So how do we plan that into our projects? How do we make that as part of the planning process so that you can enable communities to come back more quickly? They're going to need their schools. You know, they're going to need water, need there's a lot of things that critical infrastructure that is needed before a community will come back. We have to eliminate some of the barriers to innovation, so be it innovative construction techniques or innovative materials or just innovative ideas, because we have a tendency, especially in the government, that's the way we've always done things. That's not really a good answer. So, but you've got to be careful, because especially in critical infrastructure, the health, the safety, the public welfare depend upon it, whether it's TOD or DOT or, so you have to be careful. You have to innovate wisely. So how do we do that? We're working on developing techniques and means of new standards or changing standards. And then good land use planning. So don't put people, if you're doing something new or growing a part of a city, don't put them in a floodplain if you don't have to. I live in New Orleans. And then support research and development. So if you're going to use innovation, you've got to continue to innovate. So as we learn to do things better and quicker and smarter, faster, let's continue to figure that out and get it, and then make it happen. So I think that might be my last slide. Maybe one more? Okay. So really sustainability and reliability, and sustainability in the form of funding also. You need to know, I know y'all have the same problem every year. How do you plan? You don't know what's coming every year. You can't, that's hard. So, and the use of lifetime cost assessment analysis. That would be something that would be very a big benefit to any type of infrastructure. So I think that's all I have. Thank you.
Thank you, Dr. Mattei. Ms. Maines, what details or insights would you like to add to some of the energy discussion we had previously?
Thank you very much for having me here today. Thank you, Dr. College, for the introduction and the opportunity to speak here today, and thank you, AUSA, for hosting this event. That was very informative and somewhat alarming. But
I'm not a bearer of good news, I'm sorry.
But it does provide a good segue into my discussion, which I brought with me today, 2 case studies that demonstrate a range of microgrid technologies that are being installed today and demonstrate where the microgrid technologies are going. One example is a public purpose application where the financial structure is a power purchase agreement, or PPA. The other is a DoD Marine Corps application. I hope it's all right that I talk about the Marines here today. Marine Corps application under an energy services performance contractor, an ESPC. And my industry colleagues on the previous panel talked a little bit about the benefits of energy savings performance contracting, and I'm going to talk a little bit more about that today and how that fits in to the overall resilience strategy. The foundation and purpose for completing each of these was very different, hoping to demonstrate the range of applicability and design of microgrids. So Constellation, my company, is we are a project integrator, and we are an energy services company. So we are in the business of implementing distributed energy technologies through various contract vehicles. We always start, because we are essentially a design build firm, we always start with defining the problem that you want to solve, or what is the intent. And so Mr. Surash earlier today was mentioning you could start, in this case, with the design intent of the 14 days of continuous power and water in the event of an outage. Outside of that, you'd want to look at other design constraints or characteristics. Do you want grid independence, for example, reliability or power quality issues that you need to solve? Are you looking to optimize operations by interconnecting or coordinating new and existing assets behind the meter or outside the meter? Do you want to improve economics with energy and cost reductions on site, which is originally the intent of the ASPC contract, by the way? Do you want to generate new revenues through programs that are available through, for example, demand response, or for another example could be PJM, the Independent System Operators Program for synchronized reserves. So there are other revenue opportunities. And then while microgrid cannot by itself reduce emissions, the coordination of new and existing on-site assets, generation assets, can be more effectively managed to improve your overall site emissions. So if you have something like CHP, battery storage, and so forth, those assets can be coordinated through a microgrid to improve your overall emissions. So once the problem is defined for the available technologies can be evaluated. For a holistic design of a microgrid controller, this must include components such as what generation is available or planned, including grid-connected or on-site intermittent and dispatchable generation. So this might include, as I mentioned, utility generation that's outside the fence, or it might include behind-the-meter generation such as cogeneration or PV. And I think at this point in time, anybody who's considering these types of technologies should be considering some kind of coordinated controls like microgrid to implement them on site at the same time. What loads are you trying to manage? Everybody should be starting with a load study and this might take into account the 14 days of continuity. Do you need continuity of every service on site? Do you need continuity of the cafeteria? Do you need continuity of the conference rooms and all of the lighting? Or are we talking about the most fundamental services that are on site at the installation that need to be evaluated? What type of storage capacity and fuel mix is available? Again, back to the 14 days of service continuity. If you're looking at 14 days of fuel security, that's quite a substantial amount of fuel storage that you'd be required to have on site if you can imagine that, for example, both electricity and natural gas were interrupted. What other energy assets should be or need to be tied into a microgrid to optimize your overall control? As I mentioned earlier, if you're looking at energy efficiency as a strategy, or the SPC contract as a strategy to implement microgrid technologies, you should be looking at tying in energy efficiency and energy conservation measures into your overall microgrid strategy. So as I mentioned, microgrid is simply a controls strategy. It's controls integration, algorithms for supervisory controls, and the addition of the human-machine interface. You can kind of think of it like a barista at Starbucks, right? You have all of the options on site and off site to combine together into something to obtain the result that you're looking for. So the one microgrid that I brought with me today is it's the City of Hartford. It is a public purpose microgrid. The City of Hartford had major power interruptions caused by storms, both Irene and Sandy, resulting in loss of community services even with the emergency generators. So I don't know how many of you probably were directly impacted or know somebody who's been directly impacted by a superstorm, but these are prolonged outages where individuals, citizens, are looking for civil services to provide some basic functions, you know, whether it's a meal or a shower or, you know, heat or water. This community was looking to provide those support services to its community members. So their goal was to create a standalone microgrid that would link all services through fuel cell power source to provide all of their electric needs at a 10% discount. So they didn't want to incur additional costs. They wanted a payback that would make sense eventually to install this technology. So their goals were centered around reliability and economics. Now, if you think about risk assessment, as the previous panelists talked about, risk assessment there might have some challenges. And let me just take a moment to tell you about the microgrid design at the City of Hartford. So as I mentioned, it is a 800 kilowatt fuel cell that continuously operates to support or to provide electricity to the City of Hartford. But in the times of emergency, there is a manual transfer switch that switches over to provide 640 kilowatts of grid islanding. So a few keywords there. Manual transfer switch, so it's not automatically transferring over to islanding mode. It has to be manually switched over. And it's only providing 600 kW. So that's a fairly small support center for its community citizens. But it is interconnecting essential services of a gas station, a supermarket, a senior center, a school, and a grocery store. So we, Constellation, along with its partner Bloom Energy in this case for the fuel cell, were able to provide a power purchase agreement to the City of Hartford that had significant cost savings with the combination of these assets and avoided upfront capital for passive backup equipment and met sustainability objectives through the Bloom Energy solution. And that's operational today. And I do have in front of me, I didn't bring slides with me today, sort of a geography of these buildings that I mentioned, which they're relatively close to one another, so the interconnection of these was more manageable. So if you're looking at, for example, a campus that's large in size, this might be more of a challenge. Now I'm going to switch over to the Marine Corps Logistics Base Albany, and I will read to you, so we, Constellation, could determine the goal of this microgrid strategy. I will read to you the Marines on energy security. The Marines are exploring several solutions in the areas of research, including the opportunities to deploy microgrids, installation grids independent of the commercial grid that utilize power from renewable energy and other on-site distributed energy resource systems to continue functioning in the case of a blackout. The office is also working to identify points of utility and delivery system vulnerability. So keywords there: independent of the commercial grid, renewable energy, on-site distributed energy resource systems, blackout, and system vulnerability. And then the Marine Corps Logistics Base Albany had specific goals where their primary mission is to rebuild and repair ground combat and combat support equipment. It has also been selected to be the first net zero Marine Corps installation where it will produce more renewable electrons on base than it purchases from the grid. So again, we identified as their design intent there to be net zero. So their baseline concerns: grid independence and enhanced resiliency, coordination of new renewable and existing load and generation resources. So coincidentally, Constellation was also looking at installing on a contiguous site that is owned by Procter & Gamble a biomass plant. And that biomass plant is a steam-producing plant which happened to have some excess capacity. So the idea for, in support of the Marine Corps base, was to install a steam turbine generator that utilized that excess capacity from that biomass facility, and also install a distribution line in between Procter & Gamble and the Marine Corps base to transmit that power to the Marine Corps base continuously. So it's supporting its base load need, and also with a microgrid technology, it is coordinating that in the time of an outage. So their goal was to deploy a microgrid to increase reliability, stability, and security of the electrical production and distribution system on base, reduce ongoing costs incurred from having to buy from and then consequently have to produce and sell back to Georgia Power. So reliability, economics, and revenue would be their goals for their microgrid. I'll take a pause here to talk briefly about energy savings performance contracting. Generally, it is a public-private partnership where you develop energy conservation measures, and the capital cost to install those measures would be financed through a third party, and the savings that would be achieved through those energy conservation measures would support the payment of the debt on the third-party financing. That debt, by the way, is characterized as operating costs, since you're reducing your operating costs but paying back the debt service through the energy savings. So the microgrid at Marine Corps Logistics Base was installed through just this contract mechanism, through an energy savings performance contract, which actually had a number of energy conservation measures that helped support the overall payback for the combination of these projects. So generally, it was about a $40 million project. The microgrid, if it were installed as a standalone project, would be about $8 million. But by combining that microgrid project into the overall project of the other energy conservation measures, we were able to reduce the total cost through economies of scale, essentially mobilizing and demobilizing. Plus, there's an intrinsic benefit of combining the energy conservation measures such that the technologies would be compatible. So oftentimes, if you go back and you try to install a technology, it's not necessarily through the same control system. So there's a benefit there as well. So I see we're kind of running down on time. I'm going to end there, but I just wanted to give you some examples of the range of possibilities that are going on right now in the industry, and things that are benefiting the overall resiliency.
Ms. Maines, thanks. General Stone, over to you.
Great. Put up the next slide, the RCTC slide, please. Okay, so first of all, thank you for the invitation to be here, and thank you for allowing me to come back. I was here before, so I must have done something right. But I can say that I've enjoyed, as a Michigan Guardsman and as a Guardsman, wonderful support from AUSA, the AXM, IENE. I'm proud that I was asked to actually serve with IENE last year. But I think one of the reasons I'm a beneficiary is because my team in Michigan is a leader in environment and energy when it comes to the National Guard Bureau. Just this recently, our state was named the Environmental Stewardship Award in National Guard. We're competing with DA right now. This is just one example of a whole list of those. But I want to, if General Engel, the Chief of National Guard Bureau here, everything I'm going to talk about is really framed in his three priorities. We fight and win our nation's wars, we defend the homeland, and we build partnerships. So keep those three things in mind as we go through this. I put the RCTC map up here, the Regional Combat Training Center map, for a reason. As we approach BRAC, which undoubtedly is going to happen at some point, we've got to get it right, and you got to understand the Guard and Reserve a little bit when it comes to readiness, because all this is going to tie back to General Milley's quote, how do we buy more readiness? So let's talk about the history of camps. So those red dots up there, most of those are Guard installations. Those are camps. Camps are different than an active duty installation. Camp Grayling, let's talk about it. It is the 7th largest installation by acreage in the U.S. Army. I have more restricted airspace east of the Mississippi than anybody. Camp Gowan has 143,000 acres, a lot of restricted airspace. You've got a lot of training, land, remote capability, and we'll talk about multi-domain brigade in a few minutes. But let's talk about readiness of individual units. A few years ago, we had 2,900 armories in the Guard and Reserve across the country. That number is coming down quickly. We are self-bracking armories, is what I say all the time. In Michigan, I inherited 48. I'm down to 39. We're doing that for a number of reasons, but I have an advantage as a Guard general in that in my day-to-day job, I'm a state employee, as a deputy director in state government, as a general. My boss is a cabinet member of, like most states, working for the governor. And believe it or not, the governors of the states are responsible for Army readiness, by law and by agreement. So 96% of my funding is federal, 4% state. I do get some state money to make investments into my installations and enablers for readiness. So I don't have to deal with some of those issues. And a lot of states put in monies that you don't see at the DA level into some of the things that we do to enable readiness. And most of your guard installations, there are reserve installations up there, but there are more guard installations than in camps, support your Marine Reserve, Army Reserve, and other reserve components. So it's something we sometimes lose in the equation when we get funded to run our installations. Now, a camp is important. Camp Grayling has 6,000 beds. I can bed down 6,000 soldiers. I used to want to be an installation, and I wanted money, and I wanted new buildings. Guess what? Half of them aren't even heated. I'd rather not become an installation. I can deliver more readiness for General Milley by remaining a camp and a training site. So, and let's talk about Guard and Reserve units. Let's take Michigan. We've got 4 lakes surrounding us. If you're in the western upper peninsula of Michigan, Marquette, Michigan, where we've got a lot of force structure engineers that have been around and deploying since World War I, it is very hard on a drill weekend to get out of work at 5 o'clock on a Friday for a captain to get his unit all the way down to Grayling, do weapons qualification, get all the way back. It is very hard. So when we look at the footprint of BRAC in supporting readiness, keep in mind, just in the Michigan Guard, we have over 8,000 soldiers. That's over 100 deployable units that plug in and deploy all the time with multi-combo, downrange. So we've got to keep in mind, Ms. Hammock taught me, and I'm a big fan of reducing the footprints, going to larger mega armories with partners, having the resiliency package. And I will talk in a minute about, the domestic operation aspect of all of this. But also keep in mind, and I'll jump ahead to the multi-domain brigade. General Frost, the Army G3 Cyber has taught me, where are you going to do electronic warfare? If we have cities that are built around our installations, and we talked about cell towers, I want to build cell towers at Grayling, not so soldiers can have cell coverage to talk on their cell phones, because that's going to get you killed on tomorrow's battlefield, or today's battlefield. What I want is cell towers to do jamming. And so we've applied for 699 spectrums. That's at the OSD level, going to the FCC at no cost. But there's very few places we can do that where we can combine littoral. So let's flip to the next slide real quick. So just this last year, speaking of joint, we're the only jointly accredited exercise, Joint Chiefs of Staff. General Neller is committed a Marine Corps regiment annually to our exercise. We've got General Abrams has worked with Lieutenant General Lingell, has committed Guard BCTs. So we're going to get a Guard BCT and a Marine Corps regiment every year. We've been doing the exercise for years. We're not jointly accredited. That doesn't mean it's funded, but we can support the CalFAX last year we had Marine Corps regiment doing amphibious assault supported by infantry battalion, CalFAX live fire. This year the Marines are bringing Harriers. I don't know if there's any place in the Army where we can do that scale, and we're doing it about 1/10 the cost of what it would take to send a unit to NTC, because we have a problem. And General Milley, when you cannot say to General Milley, we have Guard BCTs. He will stop you right there and say, we have BCTs. We don't have enough funding to get enough BCTs to the places like JRTC and NTC to get them in the rotation mix to keep the readiness up. So how do we look at the RCTC map? Where are the places we can go to get readiness up, have exercises at lower cost to support more of those units that have to deploy? So that's really part of what we've been focusing on. We're trying to coach Gowan Field and Guernsey and some other installations into best practices. But one of the messages we want to be clear is, just because they're Guard installations, and traditionally that's where we went for our 2-week annual training together in the old days, before I joined the Army, and all those other, images you have of the old National Guard. These installations are accessible and available for the United States Army, and we host the 101st Airborne 10th Mountain Division, you know, on small battalion level size. But keep in mind when we go to BRAC, this readiness piece, and where are we going to train in lots of maneuver space that's remote to do all 5 domains. Next slide. So I'm going to switch to energy resiliency real quick. I know we're running out of time. If you build it, they will come. So this is tiny little Fort Custer. This is a 7,500 acre installation in Battle Creek, Michigan. That's a wind funnel that we're hopeful will go online here, first of its kind in June. What you don't see in the picture is a second solar field that Consumers Energy is putting in for us and will commission for us very soon. We have only a 1 megawatt peak load, and we're small. This installation does small arms fire qualification support. We get units from Chicago, Indianapolis, the whole region Guard Reserve. It's really a Guard Reserve small unit training weekend, individual soldier readiness place. However, when we started working with the National Guard Bureau and the package Consumers Energy, we're now at a place, and I'll show the next slide in a minute, where we were awarded an ESTCP. We've a microgrid coming in, a 1 megawatt battery storage. We're also an East Coast Missile Defense finalist site. And we will be at the point, if we don't have any new partners join us, where we'll actually, with a deal we've worked with the utility company, actually get a credit on our bill. 2 miles away, we have an Air National Guard base, which is an MQ-9 Reaper mission that it does 24/7. That is a power requirement. We have built the portfolio in a way where we can island, and we want to expand the portfolio that can support those mission-critical missions. We also have one of the largest Marine Corps reserve centers nearby. What has happened because of our partnerships and relationships with the utility company, local partners, is we have a lot of stray defense activities down there. We support TARDEC, TACOM, you know, individual projects at both installations. But now the Marines want to put an armory behind the fence. I already have a new Navy armory behind the fence where they opened one, closed 3. Marines want to do the same thing. The Army Reserve has an armory behind the fence. They opened 1, closed 3. We're going to build another armory behind the fence, open 1, close 3. So you kind of start to see the math of how this consolidation and cost savings can work. And then we have DLA in the neighborhood with over 1,100 jobs, and they're renting their space from GSA at an incremental cost for 1,100 employees, and they pay more than $6.5 million a year. Why? Because the cost of maintaining the infrastructure is so high. So we've already opened discussions about and have private capital ready to jump in if we have the authorities. Why don't you build a new DLA headquarters here behind our fence line and all the infrastructure the utility company's enabling? So there's going to be, and I'm not necessarily saying this should be a joint base, but you know, when we open up partnerships, go to the next slide, please. We create these opportunities for our partners. On our ESTCP project, you know, we've got Cyril on board, Zero Base Eaton, Corps of Engineers. We want to stay on all these projects with our partners, you know, with the active Army, and get the best lessons learned out of it. At about 10 more talking points, but I see we're running low on time, so I'll kind of end there and cut off all the other stuff that we were going to talk about. So thank you.
Okay, thank you, General Stone. I've got a couple of questions here that I'd like to try to get to. The first 2 are related. The first one's for Mr. Surash with regard to how many of the projects on the map that you showed us have microgrids that would allow the post to utilize the power that's generated, and do we really have much of an idea of what those microgrids might cost at an installation? And then the follow-on to that, Ms. Maines, was, are we seeing a large trend away from regional power to microgrids, and how does this decentralization enhance resilience?
Okay, so my 2-part question, I'll answer the second part first, which was how much do they cost? I don't know. But just a quick story. There's a recent Pew Charitable Trust study where they looked at emergency backup diesel generators. Our Army installations have hundreds of them typically. A large installation might have 200, 250 generators. These are typically hooked up to one building. So is this the optimum way to provide emergency backup power? What Dr. Marquesi, formerly at OSD, he pretty sophisticated study, and essentially it concludes that the lowest life cycle way ahead for the Army, the Navy, the Marines, the Air Force, anybody in the Department of Defense, is to essentially have a smaller number of generators hooked together, basically hooked together, make them into a microgrid. So that's a very interesting study. It was just released within the last month or two. So I can't answer exactly how much they cost, but I think rolled in going forward, there's definitely a play, for microgrids here. And we can spend a whole day on microgrids because there's microgrids, and then there's smart microgrids and everything in between. On the one slide of, showing the renewable alternative energy projects that you could not read, I'm sure, there were actually 20 projects on there, and you can get the slides, I'm sure. There's actually a legend on there, and so the way I'm able to answer this question is I just reviewed my slide, and we do show where we have microgrids, and 7 of the 20 projects have a microgrid of some sort. There's only 1 or 2 installations where the microgrid is supporting the entire installation. The premier example is Fort Drum. That is a microgrid setup, and probably out at Schofield, that's a microgrid setup. The other 5 are just portions at an installation, not the entire installation.
Okay, thank you. Ms. Maines?
Thank you for the question. Yes, I do see a very rapid trend or increase in the number of microgrid installations, and I think of it like any other disruptive technology, like Uber or Airbnb, where there's essentially a leveraging of assets that are owned by others, in this case, other than the utility, that are being deployed for the benefit of the end-use consumer. So the utilities are starting to recognize this, and they're starting to facilitate it. They're thinking more about leveraging the utility as a platform for these services rather than simply providing a one-way street service. So there's a lot of there's seed change going on, I think, in the industry with the utilities, with the regulations that are making the increase in microgrids and the economics around them very practical. There are some constraints, though, and I think we would see a lot more if we could lift some of those constraints around funding. There are some funding avenues at the moment, like AFFECT grants, ESTCP. We see, as a matter of fact, the Marine Corps Logistics Base Albany microgrid was in part funded by an AFFECT grant. And then, of course, the third-party financing or public-private partnership aspect of microgrids that are going to help support that through PPAs or power purchase agreements or other energy services performance contracting financing means. But there are some significant constraints, like we need to fix the budget scoring issue. We need to be able to count the O&M savings. In part, microgrids are coordinating assets behind the meter that are improving upon deferred maintenance, for example. We don't normally get to count those savings towards the benefits of microgrid. And then the blending of certain colors of money, which has always been a challenge and probably will continue to be so, but combining, MILCON funding with ESTCP or even ESPC funding would, in part, I think, help the support of funding microgrids, and we'd see a much more rapid engagement in the market with fewer constraints.
Thank you for that. General Stone, what other kinds of energy improvements would be of the most benefit for training readiness with the Army National Guard?
Well, I mean, first of all, energy improvements, I kind of want to pivot from that, if you don't mind, Doctor, of other things we're doing to save money. So let's talk about fiber for a second. Let's talk about cyber and fiber. We've run 100 gig fiber at a state in partnership to all of our installations because we see live virtual constructive coming. We had a T-BOSS system for training our rotary pilots that was funded by Guard Bureau, and it was supposed to go to an installation, went to Camp Grayling. We moved it to where the pilots are. And it was an extra cost, but we'd run the fiber, and now our training utilization is higher, and the pilots don't have to travel 100 plus miles to get to where their training is to get their readiness level up. So we are doing a number and going to continue the energy projects with our partners because we see being a camp, it's really going to be much easier for us to get to triple net zero because we're not consuming nearly as much because we're a camp. You know, I didn't mention this earlier, Grayling is ostensibly net zero for water. It's self-sufficient for water and has been for 30 years, and we never realized how strategic that was till recently. So our operating costs can be really low. So I think some of these tools, the STCPs, incremental funding, we can get to net zero pretty easily. But we also see as enablers for some of the future training as we get in these complex scenarios with fight and win in a complex world.
Okay, thank you. And one last question. Dr. Mattei, which nations are doing the best at developing and maintaining a national infrastructure, and why do you think they're being so successful?
I don't have a really good scientific, you know, being an academic, I like to have, and an engineer, I like to have the data. So I didn't get this question beforehand, so I'm just going to use anecdotal information. So I'm going to take it as a two-part question. So I'm going to separate it. So developing infrastructure. So I would think hands down that's China. Although we don't have a lot of data coming out of China, I happened to go to China I was invited to speak at a sustainable infrastructure conference in October of last year in Shenzhen. And I had to look up Shenzhen because I thought I was good in geography, but I had never heard of the city. And by the way, most of the megacities, those are 10 million and above, are in China. They've got a very long list. They are quickly becoming an industrialized country as before they were agrarian. And that is not by their people's choice. But the economy is driving it, and their economy is growing. It's starting to cool off. But as far as developing, I went to Shenzhen 40 years ago. It was a sleepy fishing village right across the bay from Hong Kong, which was not part of China, which still isn't part of China. I needed to show my passport to get between the two, which was interesting. But Shenzhen, 40 years ago, 40,000 people. It's now 12 million, depending on where you draw the lines. All new, so I get there. They're all driving nice, new, mid-sized cars. Not a lot of SUVs, but nice cars, nice roads, nice buildings. The fourth tallest building in the world in this city that I have never heard of before because I've been living in my American bubble. But it depends, I guess, on what you call the tallest. You know, I don't know what list because there's several different lists, but it's big, and I had never heard of the city. So that's what I would say would be tops as far as developing infrastructure. Now, as far as maintaining infrastructure, I would say that I might just use a country that I'm a little bit familiar with because I operate in the flood control world, and so I'm going to talk about just flood control infrastructure. That would be Denmark, because they deal with riverine flooding and they deal with storm surge. And it's a small country. Most of their population is at risk. So it's a national priority. So yeah, they have good infrastructure when it comes to flood control, and they maintain it because it's a matter of survival. So it's a national priority.